My name is Ramesh HG, Assistant Professor of Mathematics, Government First Year College Tiptur. I am going to explain algebraic structures and their properties with some examples. A non-empty set with one or more binary operations is called as algebraic structure. A non-empty set means set consisting of at least one element with one or two binary operations is called as algebraic structure. For example, set of natural numbers is an algebraic structure with binary operation, addition as well as multiplication. If you consider set of natural numbers, addition as binary operation, then if you add any two natural numbers, say 1, 2, 3, 4, 5, 6, say 2 and 3, it is 5, 5 is also natural number, 5 plus 7, 12, 12 is also natural number, like that. Set of all natural numbers is an algebraic structure with binary operation as addition, and also with multiplication 2 into 4 8, 4 into 5 20, they are also natural numbers. So set of all natural numbers is an algebraic structure with binary operation as addition as well as multiplication. So before going to algebraic structures, we require some knowledge about numbers and their number system. We shall study some basic ideas about number systems and numbers. So there are several number systems. So important number systems are set of all natural numbers, n denoted by n, set of all integers denoted by z, set of all rational numbers, it is denoted by q, set of all irrational numbers, it is denoted by q dash, set of all real numbers, it is denoted by r, set of all complex numbers, it is denoted by capital C. So you observe that natural numbers, so it starts from 1 to 3 and so on. Integers consisting of positive integers as well as negative integers and 0. Rational numbers, it consisting of fractions as well as integers. Irrational numbers, it consisting of irrational numbers, that means they cannot be expressed in the form of p by q, whereas rational numbers can be expressed as p by q, where p and q are integers, and irrational numbers are not rational numbers, and union of rational and irrational numbers are called as real numbers, and complex numbers are the numbers of the form a plus ib, where a and b are real numbers, I is imaginary number. So this is a number system. Come to the first set, the set of natural numbers, it is denoted by the capital letter N, and it consisting of the numbers 1, 2, 3, 4 and so on. And these are infinite in number. One can observe that the sum of two natural numbers is also a natural number, and product of two natural numbers is also a natural number. So 2 plus 3 is 5 is a natural number, 3 plus 6 is 9 is also a natural number. If you take product 10 into 3 30, that is also a natural number. 5 into 10 50, that is also a natural number. So we can say set of all natural numbers is an algebraic structure with addition as well as multiplication. Set of integers, it is denoted by the letter z, and this consisting of say minus 3, minus 2, minus 4, minus 6 and so on, minus 1, 0, 1, 2, 3, etc. And here the 1, 2, 3 and so on, they are called positive integers. Minus 1, minus 2, minus 3 are called negative integers and included 0. So this big set is called a set of integers and which is denoted by the letter Z. Here also you can observe that the sum, product and difference here, difference of two integers is again an integer. So if you take 2 plus 3, 5, 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 1 is 2. So they are all integers. Sum is integer. Product 1 into 2 is 2, 2 into 3 is 6, minus 1 into 1 is minus 1, 2 into minus 3 is minus 6. It is again an integer. Difference 3 minus 2 is 1, 2 minus 3 is minus 1, that is here. 3 minus of minus 2, that is 5, it is also here integer. So sum, product and difference of two integers is again an integer. Therefore it is an algebraic structure with binary operation as sum, product and as well as difference. So set of all integers is denoted by Z. It consisting of all these numbers, positive integers, negative integers and including 0. Sum, product and difference of two integers is again an integer. So this is some ideas about the integers. So integers here diagram, integers is consisting of positive integers, negative integers and 0. Set of all rational numbers denoted by Q. Set of all rational numbers denoted by Q. And this consisting of the numbers of the form P by Q, where P and Q are integers and Q is not equal to 0. So this is one of the big set which include integers as well as natural numbers. So rational numbers include integers and all the fractions. So example 1 by 2, 3 by 2, 4 by 7, 10 by 3, etc. These are all fractions. They are included in rational numbers. And integers, say 10, 10 by 1, 5 by 1, 6 by 1, they are also in the form of P by Q, and hence they are also rational numbers. Here also the sum, product, difference, also binary operations. And you observe that the division of two rational numbers except denominator is not equal to 0. So 5 by 0 is not allowed, 6 by 0 is not allowed. So 0 by 3 is 0, 0 by 10 is 0, but 10 by 0 is not allowed. So denominator is not equal to 0. So sum, product, difference and division of two rational numbers is also a rational number, except for division case, denominator is not equal to 0. So this is one of the big set rational numbers, set of all rational numbers. Set of all irrational numbers denoted by Q, and these cannot be expressed, cannot be written or expressed in the form of P by Q. P and Q are integers. So the numbers which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. So the set of all rational numbers is denoted by the letter Q dash, and root 2, root 3, root 5, root 7, root 8. Root 8 is 2 root 2. These are all irrational numbers. These are all irrational numbers. And the well-known number pi, that is the circumference of the circle divided by diameter. The ratio 22 by 7 is approximate value. So that is 3.1416. This is also a irrational number. The number E exponential number is also a irrational number. And this we call it as a irrational set. It is denoted by Q dash. The set of all real numbers are denoted by R. This is the union of rational and irrational numbers. So one of the big set, the set of all rational numbers and set of all irrational numbers, union, you take union, that becomes a real number. So real number include all rational numbers and irrational numbers. So one can say what is root 2? Root 2 is a real number, root 3 is a real number, 1 is a real number, 2 is a real number, 0 is a real number, 10 is a real number, 1 by 5 is a real number. All numbers are real numbers, and that is the union of q and q dash, that is set of all rational numbers and set of all irrational numbers, that becomes a set of all real numbers. The set of all complex numbers, it is one of the biggest number system. Set of all complex numbers is denoted by the letter C. The numbers of the form a plus ib, x plus iy, 2 plus i3 are called complex numbers. And here the first number a is called as real part and b is called imaginary part. For example, 2 plus 4i, 10 plus 3i, here 2 is real part, 4 is imaginary part. And 10 is real part, 31 is imaginary part, 10 is real part. So where A is called as real part and B is called imaginary part. So this is one of the biggest number system. This is also an algebraic structure with addition, multiplication, subtraction, and not for division. Division is not allowed for q is not equal to 0. So this set complex numbers is denoted by C, and the numbers are in the form of a plus ib, are called complex numbers. So in integers, particularly in integers, the numbers can easily divided into two even numbers and odd numbers. Even numbers are multiples of 2, odd numbers are not multiples of 2. For example, 2, 4, 6, 8, 10, these are even numbers. 1, 3, 5, 7, these are odd numbers. So the even numbers are the numbers which are divisible by 2. The odd numbers are the numbers which are not divisible by 2. So the definition of even and odd numbers. The prime and composite numbers. What are prime numbers and what is the composite numbers? So you consider 7. So the divisors of 7 are 1 and 7 itself. That we call it as a prime number. You take 5. The divisors of 5 and 5 are 1 and 5. It is a prime number. 7 is a prime number because the divisors are 1 and 7, 1 and 5, etc. Suppose if you take 10, the divisors of 10 are 1, 2, 5 and 10. So it has divisors other than 1 and 10. So it is a composite number. It's a composite number. You take 6, the divisors are 1, 2, 3 and 6. You take 4, 1, 2, 4. You take 8, 1, 2, 4, 8. You take 9, 1, 3, 9. So all these numbers have divisors other than 1 and itself. But 2, 3, 5, 7, 11, 13, 17, these are the prime numbers which have only divisors as 1 and itself and no other divisors. So therefore these called as prime numbers and these called as composite numbers. And this is about an algebraic structure in detail, and glance about the algebraic structures and set of all integers, set of all natural numbers, set of all rational numbers, set of all irrational numbers, set of all real numbers, complex numbers, and even odd numbers, prime and composite numbers. So set of all natural numbers is denoted by n, set of all integers is denoted by z or I, set of all rational numbers is denoted by q, set of all irrational numbers is denoted by q dash, and set of all real numbers is denoted by r, set of all complex numbers is denoted by c, and an algebraic structure is an unempty set with one or two binary operations is called as an algebraic structure. So set of all natural number is an algebraic structure with addition and multiplication. Set of all integers is an algebraic structure with addition, multiplication and difference as binary operation. And similarly set of all rational numbers, set of all real numbers, these are all algebraic structures. So we discuss in next class in detail about these algebraic structures. So the very important algebraic structures are group structure, ring structure and field structure. These will study in the future class. Thank you.